This is part 2 of section 10.5, so this is where we're going to be getting into problems with trigonometry. We need to recall the vocab that we learned in the video from last night. So if we have any regular polygon, it must be regular. Then we have a radius going from the center to a vertex, and we have the apothem, which is from the center to a side at a 90-degree angle. So we're going to jump right into a couple of problems here. My first example is you have this regular nonagon here, and they give you the side length, but they don't tell you what the apothem is. So if you remember the formula that we learned yesterday, it's that your area equals 1/2 AP, where A is your apothem and P is your perimeter. So at this point in time, we can determine what our perimeter is, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. Each of those 9 sides measure 10 centimeters. So 9 times 10 centimeters, I know that my entire perimeter is 90 centimeters. So I can plug that value in. I can bring my 1/2 down. But I don't know what my apothem is, and this is where trigonometry comes in. We learned how to determine what this central angle here is. That's half of a central angle though. So I'm going to take my 360 divided by 9. When I do that, I get 40. But 40 would be this whole angle right here, the entire central angle. I only want half of that. So I know that that angle is going to be 20 degrees right there. So if that's 20 degrees, I know that this whole length here is 10 centimeters. So this little piece here is 5 centimeters. And I can find the length of my apothem by calling it x and using trigonometry. So if I draw my little person standing at that 20-degree angle, 5 centimeters is the side opposite of my 20 degrees, and x is my side that's adjacent. So I'm looking to use tangent of 20 degrees equals opposite over adjacent. So now because our x is on the bottom, we know that we have to flip these two things. So I get x equals 5 over tangent of 20. When I put that in my calculator, I get that x equals 13.7. I'm going to round it to the nearest tenth. So that's the value of my apothem. That is what I can put into my formula. Now, we were really, really good at this. We take 0.5 times 13.7 times 90, and we get that our area is 616.5 centimeters squared. So that would be your final area of that problem. So again, just to remind you, we know our perimeter because we have one of our sides, but we have to then set up some trigonometry using this triangle right here. We can find this angle at the top because we know that's half of our central angle. So we took 360 divided by 9, got 40, and then sliced that in half. So we have tangent of 20 degrees equals 5 over x. Because we have our 5, we're looking for x, and we know our 20 degrees. Once we solve for x, we now have our apothem. We plug that into our original area formula, and we're good to go. So you tried this problem here, please. So here we've got another example of the same thing. They give us a stop sign. They say the stop sign is an octagon, so that's good to know. We should definitely know that a stop sign is an octagon so that we can do this problem. The standard size has a 16.2-inch radius. Okay, so let's draw that in. I'm going to switch. I'm going to use white because I think that'll show up here. So there's my radius. And we know that that is 16.2. That's going to be kind of hard to see. 16.2 inches. What is the area of the stop sign to the nearest square inch? So I need to use 1/2 AP. But here, that 16.2, it's not my apothem, and it's also not my perimeter. So I'm going to have to do a lot of work here. Let's draw in our apothem. Let's draw that down the middle, my 90 degrees. And we can start doing trigonometry, but we're going to have to do trigonometry twice because we can find this central angle here. If I have an octagon, I do 360 divided by 8 sides. That gives me 45 degrees. But I don't want the full 45. I want to cut that in half. So I know that my central angle, my half a central angle, is 22.5. So that's the angle that we're going to be using, 22.5. Now, let's see, we have to put, let's call this X, our apothem X. That's what we're going to look for first. Then we're going to go through, we're going to try to find our perimeter. So let's call that Y. Those are the two different values that we need to find so that we can do this problem. So if I'm standing at my angle, sorry, it's kind of hard to see on this stop sign. Standing at my angle, I'm looking across my angle, I see Y. Well, if I'm trying to find X, X is my adjacent side to where I'm standing, and I have my hypotenuse. So if I have my adjacent being X, and my hypotenuse is 16.2 inches, I have adjacent hypotenuse, I can use cosine. So I can set up an equation, use cosine of 22.5 equals adjacent over hypotenuse. Okay, cool. So my X is on the top. That means I multiply these two things. 16.2 cosine 222.5 equals X. I put that in my calculator. Cosine 22.5. And I get that X equals 14.966. So I'm going to round that to 15. Write that neater. I'm going to round it to 15 inches. So that's X, which is really my apothem. So that's going to be helpful. I'm going to plug that in over here. 1/2 my apothem is 15 inches. But now I have to go back and I need to find my perimeter. And in order to do that, I need to find this little piece right here. So I'm going to set up, that's my opposite side. So my opposite side is Y, and my hypotenuse is 16.2 inches. So now because I have opposite and hypotenuse, I'm going to use sine. So sine of 22.5 equals opposite over hypotenuse. So I'm going to multiply those, and I end up, I'm going to move my work down here into the U try space. I get Y equals 16.2 sine 22.5. I put that into my calculator, and I get that Y equals 6.199. So I'm going to round it to 6.2 inches. Okay, but that's not what I'm plugging in, because that is just this little piece right here. So in order to find my perimeter, this little piece, I'm going to double to get a side. So let's take that, let's multiply it by 2 to get my side length. I need S. So 16.2 times 2, or I'm sorry, 6.2, I get 12.4. This is a side. Now that I have a side, I'm going to multiply that by 8 because I have 8 sides. I get 12.4 times 8 equals 99.2. That is what I can put in for my perimeter, 99.2 inches. And now I just calculate my area based on this formula right here. So 0.5 times 15 times 99.2, I get that my area is 744 inches squared. So you go ahead, there's one more U try for you to do there. And then the next thing we have here is area of a triangle given SAS. So these are going to be pretty quick problems. It's just this formula that you have to memorize here. if you take 1/2 times your 2 sides and the sine of the angle in the middle, that's going to be another way to find the area of a triangle. So if you do not have like the base and the height, you can also find area of triangle using this formula here. So let's look at the example. I'm going to plug in 1/2 my 2 sides. My 2 sides are 12 centimeters and 21 centimeters. And then I'm going to multiply that by the sine of that angle in between them. So let's do that. 0.5 times 12 times 21 times sine 48. I get that my area equals 93.6 centimeters squared. So all I have to do is I have to multiply using this formula, 1/2 times each of my 2 sides times the sine of my angle in between them. So you're going to go ahead and do that. You try there. You're going to use the same formula, and I'll see you in class.